Hi everyone, welcome to Knowledge Center. In this session, today we will discuss about double-ended clipper circuit, or it can also be named as two-panel circuit clipper. Okay, so here, as the name indicates, we will have two diodes connected in parallel to the supply. But the positions of diode or something, it may be depends, they may vary it. Now I have taken one diode in this position and the other diode is opposite to that. So now let's see what would be the output of this type of a circuit. As there are two types of parallel diodes, that's why it is named as two-way parallel clipper circuit, right? And this is going to clip two portion. We have an input here. Let's see, once we'll analyze it, let's see what would be the output. So based on that output, we have the name for this circuit as a double-ended circuit. So let us understand how to analyze and get the output for this type of a circuit. So here we have two diodes. First let us consider this diode D1, and we have an input as 18 volt. Sorry, the input is 18 volt. So let me write it here. This is 18 volt AC supply D1, and this is the voltage, reference voltage 9 volt here. So when we consider this, we need to understand what would be the voltage drop at this point. So let me consider these diodes are made up of silicon. Both these diodes are made up of silicon. So we can have an equivalent circuit of this. The equivalent circuit will be like this. We can have a supply. This diode can be replaced by the source. Silicon diode is nothing but there will be a drop of 0.7. So replace this diode with its voltage drop. This is anode, so it has to be positive terminal. This is cathode, so that should be mentioned as a negative terminal, which we have already discussed in the earlier videos. So this is how we can replace it. We get here 0.7 volt. That is the drop because of the silicon diode, and this is negative and positive because anode is here. So just replace it using the positioning of the diodes, and this is the source given. We get output here. This is 9 volt, whereas this is given as 7 volt, and here again you will have 0.7 volt drop, but this is minus plus plus minus, and this has to be plus minus plus minus. Have a note of that. Then what we can do is, next we can find out the voltage drop at this particular point. For to do that, we will read this circuit like this. So minus to plus, it is plus 9, and this is moving minus to plus, so it is plus 0.7. So totally plus 9 plus 0.7, we get 9.7 is the voltage at this point. So we can write it here as, here the voltage we get is 9.7. That is the barrier voltage, right? So we have a 9.7 at cathode. So if you want to turn on this diode at this anode, I have to give the voltage which is greater than this 9.7. That's the point. Same way you can find the voltage at this point. So here how can you do same, apply the same concept, read it like this. Mine is plus to 7, plus to minus, so it will be minus 7. Then this is also moving plus to minus, so minus, and what is the voltage drop? 0.7. So totally it will be minus 7.7 volt. So you can say here we have minus 7.7 volt at this anode, and here I have a cathode. So cathode has to be lesser than this anode. So cathode should be less than minus 7.7, then only it is going to contact. So there are two conditions now. First let me write the condition for diode 1. So diode 1 will conduct, it is going to be on if anode is having greater than this. And what is the anode, from where I am getting input? The input is given to anode. So I can say input V in. If input is greater than 9.7, at that condition what happens? This diode will be on. D1 is on if V in is greater than 9.7. That's the point. Okay. So when it is going to be on, you can also write it as equal. Okay. So what would be the output? Now we need to write the output for this condition. If it is on, what would be the output? Here you can't write output by just looking at this position, this diode, because we have another diode in this circuit. You need to see whether this diode is on or off. Okay. So for that what we will do is, if I give a greater than 9.7 means that is a positive value. So if I give positive value here, this diode will not turn on, because if I give 9.7 and above at the cathode, then anode is having negative value. So cathode will be greater than anode. If cathode is greater than anode, then diode will be off. So in this input, let me take this. So this is 9.7. So if the voltage is above this 9.7, then only this diode will turn on. This is going to be off. If this is off, we can say that this is open. So if that diode is open, we won't get any current here. So whatever the voltage we will have, that will be equal to the voltage what we have in this branch, in this portion, right? So this voltage will be equal to voltage across these two terminals. And what is the voltage we have here? That is 9.7. So V out is going to be constant 9.7 volt. So if the input is greater than 9.7, for this region of input, output will remain constant 9.7. That's what we found now. Okay. Now this is about diode 1. Now let's see what happens if diode is off. D1 is off. If input is less than 9.7, if input is less than 9.7, D1 is going to be off. Just reverse of it. So at that condition, V out is going to what will be the output. So whenever diode is off, we can easily say that output will just follow the input. But for how long? Because we have another diode here. So if you have two diodes in a circuit, first write the on conditions. After that we can go for an off condition. So now I will not go for writing the expression for this off condition, because I have another diode here, right? So this is diode 1. When it is on, that will be the output. Now same thing you apply it for diode 2. So diode 2 will be on at what condition? Let's write it. So here we have minus 7.7. If this voltage, means the voltage at the cathode, if it is lesser than minus 7.7, then only diode will on. So we are getting input from here. So we can say if Vin is lesser than the voltage minus 7.7 volt. If the cathode voltage, if it is less than minus 7.7, then diode will on. So D2 is on. So I can write here D2 will be on. Okay. Now in this input you can say somewhere here, say this is minus 7.7. Let me name this as minus 7.7. So this region means below this. If input is less than minus 7.7, diode will on. This diode will be on. And what about this? Say you need to apply for this diode also. So when input is minus 7.7, here I get minus 7.7. This is anode and cathode is plus 9.7. So cathode is higher in potential, means diode will not conduct. So this diode will be off. So it is very clear here. If this diode is on, this will be off, and this is on, this will be off. Okay. So first you need to write the conditions at which both the diodes are on. So this is the first condition I have written. When D1 is on, at that time this is off, and when D2 is on, at that time this is going to off. So we can say what would be the output now. This is off, means we can say that the output, this will be open circuit. So the output will be just following the voltage what we have here. It is just exactly voltage across this. And what is the voltage across this branch? It's minus 7.7. So output will be minus 7.7. So it means that if input is less than minus 7.7 or equal to minus 7.7, because when it is on you write it like this, then the voltage will remain minus 7.7. Output will remain minus 7.7, that is constant. Okay. So we got an output for two conditions. If it is on, if it is above 9.7, it is constant. If it is below 7.7, it is constant. In between, what happens in between? So this is in between range. In between these two, both the diodes will be just off condition, and it will just follow the input. So let's check it out over there. If diode, for example, if input is, assume, if input is somewhat 5 volt or 9.6, if input is 9.6, then what happens to those two diodes? Let us consider it. So we get 9.6 here, even 9.6 here. So 9.6 is lesser than 9.7. So diode will be, this will be in off condition. D1 is off, and this is positive, this is negative. Anode should be higher, so here anode is low, so this will be off. So same way happens in between this, both the diodes will be off. So when both diodes are off, output will just follow input. This is the solution or a values what you get here. Now if you want to represent it in the form of an output waveform and a transfer function or a transfer characteristics, let's see how to draw it. So let us represent the output waveforms now. So to do that, let me take this picture, this positioning over there. Okay. So see, this is input, where we have this as minus 18, this is plus 18, and somewhere here you got 9.7, and this is say minus 7.7. Those are the two breakover voltages we got. So just expand this, extend these lines over there towards the here, so that I can get the output here. So up to 9.7, when voltage is moving up to 9.7, it is going up to 9.7, diode is off. Diode will be on only if it is beyond the 9.7. So diode will just follow. When it is off, it will just follow. See, up to this condition, it will just follow. Output will follow the input. I can say that. Here I can draw it as output will follow the input. There itself I will draw it. So until and unless you reach 9.7, output will just follow the input. Once you reach the 9.7, if it crosses it, diode 1 will be on and output will remain constant. So output will remain constant, that to 9.7, so it will be constant like this. Okay, output will remain constant. That is the picture. Okay, so once output is constant, how long it will be? Unless and until it is greater than 9.7 or equal to. So here what happens, this portion input is reduced, input is less than 9.7. So now this will be off and it will follow the output. So next point what we have, diode D2 is up to minus 7.7. D2 will conduct only if it is less than 7.7. So it will conduct for this region. So this is going to be clipped and this is going to be clipped. So what we have clipped it over there. So at the negative side we get it like this. And in between this diode will, input will just follow, output will follow the input. So in between this what you need to do is just put as it is what we have as input. Okay, so it will continue. You get it like this, right? So this is what the output will be. Positive portion is also clipped, even negative portion is also clipped. That's the reason it is called two-way parallel circuit or double-ended parallel clipper. Okay, I hope it is clear how to get the waveform. Now let's put a characteristics. Let's see the transfer characteristics of this output. So I'll explain it easily how to draw the characteristics. So output characteristics will be how to represent the output characteristics. So we know that output characteristics are nothing but it is input voltage versus output voltage. Say this is input, this is output, minus V out minus V in. Okay, so we have, this is constant at what time? 9.7. So if input is, say if input is 9.7, somewhere here let me take this as 9.7. Okay, and output will also be constant, and output will also remains 9.7 as a constant, positive side. So I am taking this region, positive side. So this is how it will be. If input is greater than 9.7, output remains constant 9.7. That's the condition we had. So we can just take this line, constant line here, right? It will remain constant. Same way negative side, minus 7.7. So input also minus 7.7, somewhere here minus 7.7. Output, take it minus 7.7. So this is minus 7.7. So take a point, this is the point where it come in contact. So from here what we can say, this output will remain constant minus 7.7. This is constant minus 7.7 once we get the negative region. Okay, so in between this 9.7 and minus 7.7, it is just following, output is following the input. So output is following the input is nothing but the slope will be 1. Slope will be 1. So that part already I have explained how to draw the transfer characteristics. That was explained in my previous videos. You can check it out over there. So it just follows the input. So we will get a slope as 1 and that we can join it like this. It's a straight line. It will be a straight line crossing the origin. So this is the transfer characteristic of this particular circuit and output. I hope this is clear. If you want to understand more about the transfer characteristics, go through my previous video. It has been displayed or given in the description. If this is clear for you, like the video, share among your friends, and don't forget to subscribe to my channel. Thank you.